In exercise 13.5, we find Smith and Jones on a desert island, and they only have slices of ham and cheese, and Smith is a very choosy eater, so he will only consume ham and cheese in fixed proportions of 2 to 1, and Jones is more flexible. Actually, he's very flexible because his utility function is one of perfect substitutes. And they are stranded with an endowment of 100 slices of ham and 200 slices of cheese. And what we need to do is to draw an Edgeworth box in A, representing all the possibilities in which they can allocate the cheese and ham among each other. And in B, we start with an initial endowment of each, and what would then be the equilibrium. The same in question C. And then there's a bonus question D. So let's start out with A. So 100 slices of ham and 200 slices of cheese gives us the following Edgeworth box, where on the horizontal line we have the cheese, and the vertical represents the ham. Well, we have twice as many slices of cheese than we have slices of ham. So the total endowment of ham and cheese is 100 and 200, and that determines the Edgeworth box. And then here we have the origin of Smith, where Smith doesn't have any cheese and not have any ham. So that's not very attractive to him. He probably wants to move in this direction. Whereas Jones, at this point over here, the top right corner, has 0 slices of ham, 0 slices of cheese. So Jones wants to move to the down right in order to increase his utility. But this is a specific situation where one of the two has ham and cheese as perfect complements and the other one as perfect substitutes. So how does it work? First, notice that for any price ratio that is not equal to 3/4, we will find a corner solution for Jones, because Jones is perfectly flexible. So if the price ratio is not equal to 3/4, he will decide only to consume cheese or only to consume ham. So, for example, suppose that the ratio is 1/2, meaning that cheese is twice as cheap as ham, then he will decide to only consume cheese. But a corner solution for Jones, where Jones consumes all of the cheese or all of the ham, is really not attractive to Smith because he consumes them in fixed proportion. So any corner solution for Jones would give Smith a utility of 0. He really needs and ham and cheese in order to get a positive utility. So that cannot be an equilibrium because Smith will not agree with it. And Smith only wants to consume ham and cheese in a fixed proportion. So he wants to consume half of the slices of ham as he consumes slices of cheese. And would you give Smith more ham, then it has no use to him because it doesn't increase his utility. So we can make Jones better off by giving the surplus ham to him. It doesn't decrease Smith's utility, so in any equilibrium he will consume them in this fixed proportion. So in a nutshell, two conditions need to be satisfied by any equilibrium. The price ratio needs to be equal to 3/4, and the consumption of ham by Smith is half of his consumption of cheese. Which means that the contract curve is a straight line with a slope of 0.5. So if we increase the consumption of cheese by Smith, then his consumption of ham also needs to increase by half of the increase of the consumption of cheese. So the contract curve is a nice straight line with a slope of 0.5. And any Pareto efficient allocation must be on this straight line. And now we are ready to start with question B. So suppose that initially Smith has 40 slices of ham and 80 slices of cheese, and the remainder is owned by Jones. what is the equilibrium position? Well, in this particular allocation, we see that for Smith, actually his slices of cheese are twice the number of the slices of ham. So actually, this point is on the Pareto efficient set. And no trade is possible that would make one of the two better off without making the other one worse off. Because if Smith would give either a slice of ham or a slice of ham cheese to Jones, then Jones would benefit, but the utility of Smith would go down. So no consumer can be made better off without making at least one other consumer worse off. So the initial endowment is an equilibrium allocation in question B. And we can depict it graphically. So this is our Pareto efficient set, and this initial allocation is right at the Pareto efficient set. So no beneficial trades possible. Now this changes, so this is this changes if we change the initial endowment. So now suppose that the initial endowment is where Smith has 60 slices of ham, 80 slices of cheese, so not a ratio 2:1, and 40 and 120 are owned by Jones. So the initial allocation is now at this point over here, the blue dot, and we already derived in question A that the budget line needs to go through the initial endowment and needs to have a slope equal to -3/4. So the budget line is the one that is over here. And in equilibrium, we also need to have that Smith's consumption of ham is half of his consumption of cheese. So in equilibrium, it also needs to be that the allocation is on this line over here. Now, there's only one point that is both on the Pareto efficient set and on the budget line, which is the green dot over here. And we can compute the allocation at this point. So first we take the, without loss of generality, we take the ham as the numeraire good. So we fix the price of ham at 1. And for Smith, we can now compute his budget. So he owns 60 slices of ham, which have a value of 1 each. And on top of that, he owns 80 slices of cheese with a value of 3/4 each, because this needs to hold. So his total budget is equal to 120. And then Smith can choose any point on this line over here. So his consumption decision, what he will choose is a consumption of ham that's half the number of slices of cheese. So we plug this into his budget constraint. His budget is 120. He can spend it on ham and cheese, but his consumption of ham in equilibrium is half of the consumption of cheese. So we replace the HS over here by C divided by 2, and we solve this one for the consumption of cheese. And we find that the consumption of cheese in equilibrium is equal to 96, and then his consumption of ham, so well, he buys 96 slices of cheese from his budget of 120 at a price of 3/4 each, which leaves a budget of 48 to spend on ham, and the price of ham is equal to 1, so he can buy 48 slices. And given that we have an economy with 100 slices of ham in total, if in equilibrium Smith consumes 48, then Jones necessarily will consume 52. And this equilibrium allocation is the point, the green dot over here. And you can see that this is the point of intersection of our budget line with the Pareto efficient set. And that solves question C. And then question D, the bonus question. Suppose that Smith, who is the stronger of the two, decides not to play by the rules of the game. what would then the final equilibrium position be? Well, if Smith can just knock out Jones, if need be, then the equilibrium allocation will simply be that Smith will get all of the cheese and all of the ham, giving him a maximum utility, and he will leave Jones with nothing. And fortunately, in real markets, we have rules such that it's not a power of force that will determine the equilibrium outcome. But if so, this would probably happen. And that concludes exercise 13.5.